all the same size as the, I think that's called an equilateral because they're equal. So there's something special that we talked about last time. And I'm going to draw this. So this would be a right triangle if I have this little square in the corner. Do you remember what that means? That's okay if not, I'm just trying to see.
90 degrees.
Good, yes. So a right triangle, that's the 90 degree angle. So any right triangle has a 90 degree angle. And if we have a 90 degree angle in our triangle, then we have some things that are true. So we have some relationships on this triangle. So let's label our sides. So this is always called our hypotenuse. There's some pencils on the back table if you need to borrow a pencil. So this is always our hypotenuse. And then we usually are talking about some angle. Hey. Oh, sure. Yeah. Thank you. So if this is the angle we're talking about, so maybe I'm going to call that theta. Theta is a really common angle name. So this thing is called theta. Then we have some relationships that we're going to talk about. So we've got this side this is called the opposite side. So if I'm looking at this angle, then the side that's across from that angle is called the opposite side. That makes sense. The one that's right below that angle, that's not the hypotenuse, but it makes up the other side of that angle, this is called the adjacent. I should probably do that in a different color. Let's see if we can do that in a different color. So this side down here is our adjacent side. This side over here is called our opposite side. And then we have I'll just do this one in the blue. This is our hypotenuse. Does that make sense? Okay. So we have some relationships that we are going to use today. So the first one is the sine of theta, and that is the sine is the opposite side over the hypotenuse. So this is just a relationship that's useful if we have a 90 degree angle. So, and we have another angle. The sine of this angle is the opposite side over the hypotenuse. Okay. Questions so far? We're doing okay? Okay. Does this sound familiar? Not yet? Okay, that's fine. You're supposed to learn this in secondary math too. So sometimes people have heard it before. I'm just checking. The next one is called the cosine. So this name is sine. This is cosine. But on your calculator, it will look like this, COS, cosine. The cosine of theta is the adjacent over the hypotenuse. So this would be, if we have this side length, it's going to be this side length over the hypotenuse length. And then the last one we have is tangent. It's called tangent. And we write it like this. We write tan of theta. And that is the adjacent over I'm writing it wrong. It's opposite over adjacent. Opposite over adjacent. our adjacent side over the opposite side. So we just have to figure out what angle are we talking about, and for that angle, which side is opposite, which side is adjacent, which side is the hypotenuse. So a lot of the time in math, we will use an abbreviation. We will use, this helps us to remember. It's like a mnemonic device, and we use so, ka, toa, SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So if you just remember SOHCAHTOA, you can break it down and you can figure out the relationships. Okay? All right. We're good there? So we are going to use, first we're going to practice these, and we'll do some of these together. First we're going to practice just writing these relationships. The next thing that we're going to do is we can use these to find a missing side. So if I have a triangle, and it must be a 90-degree angle, triangle, so it must be a right triangle, and maybe I have this angle over here. Maybe this angle is 30. I'm just making up a triangle. And maybe this side, maybe I don't know this side. Okay. But maybe, maybe I have the hypotenuse. Maybe I know that this side is 15 feet. So the angles in degrees, this is just a number. Okay. So I can use these relationships up here, and I can find this missing side. So what do I have? I have the opposite. I have the opposite side. I'm going to abbreviate that. So I have opposite. And I have the hypotenuse. So if I look through my list, if I have opposite and hypotenuse, then I can use the sine. So I know that this is true. The sine of theta is the opposite side over the hypotenuse. So then I just fill in what I know. So I know the sine of 30 degrees is x over 15. And then I just have to solve for x. Okay? So I want x by itself. We have x divided by 15. So the opposite of divide is multiply. So if I multiply both sides by 15, then I have x is 15 times the sine of 30. So then I have a calculator up here, and you guys can use a calculator too. I think that would be useful to use a calculator. So I also need to make sure that my calculator is in degrees. So I don't know if you can see that. So if you push this button on this calculator, DRG, I have degrees, radians, or gradients. Okay, and I can scoot between them. We want to use degrees. So this calculator is already in degrees, so we're good. So we just push enter. So I'm just going to do 15 times sine. So right here I have sine, cosine, and tangent. That's what we're going to use. So I just do 15 times the sine of 30 in parentheses, and I push enter. And I just found that if I have a 30-degree angle with a 90, with a right triangle, and the opposite side is unknown, and the hypotenuse is 15, we just found that this is 7.5. Okay. Questions on that? We'll do some examples too. All right, so we can find a missing side. The other thing we can do, let me flip over this example, is we can find if we have a right triangle that has a 90-degree angle, and we have, maybe this side is 50, and this side is 30. And we want to know what is the angle here. We can find that angle. So this angle, this side would be, what side would this be? Would this be opposite, adjacent, or hypotenuse? This one with 30. Good, this would be adjacent. It's making the bottom of the angle. Good. And then what is 50? It's kind of also adjacent, but it's across from the 90. Good, that's going to be our hypotenuse. So looking at our relationships, do we have any of those? Do we have one that relates the adjacent and the hypotenuse?
Yeah.
Which one?
Cosine.
Good. So cosine of this angle, cosine of 30, gives me the adjacent side, which is 30, over the hypotenuse. Okay. So now we have to learn something called the inverse. We're going to use the inverse cosine. So what we're going to do is like if we had x squared and x squared is 4, how do we get rid of the square root? We would have to do this, or excuse me, how do we get rid of the square? We have to square root, right? And we'd have to square root both sides. That's the inverse. So here, we're going to do this. The inverse cosine is cosine with a -1. So if we have cosine of theta and I'm looking for theta, what I'm going to do is I'm going to do cosine inverse of cosine equals, and then if I do it on one side, if I do the cosine inverse on one side, I have to do the cosine inverse on the other side. It's like I'm undoing the cosine. So these cancel. Cosine inverse of cosine, that cancels out. And then I have theta on this side. And then I can just type this in my calculator. So it's not too hard. If I go second cosine, that gives me the inverse cosine. And then I just type in 30, oops, that's 30 divided by 50. End parenthesis. So we just found that that angle is 53, and I'm going to round to 1 decimal place. 53.1 degrees. Okay, questions on that? Okay, that's all we have to do today. So on this packet, there's 30 questions. Once you get done, you can work on other classes. So we're going to go over one of each together. There you go. And then you can just, I think you'll be able to work on it the rest of the time. All right, let's get a little bit closer. Oh. There we go. All right, so look at the front. We're going to do one of the front type. Do you want to do sine, cosine, or tangent? Or any numbers? Do you care?
4.
4. Okay. So here's 4. It says find the cosine of C. So C is this angle. Okay, so this would be A up here. B is the 90-degree angle. C is here. So first let's label the pieces. So 17. What would we call 17? Opposite, adjacent, or hypotenuse? Good. It's across from the 90, so 17 is our hypotenuse. And I'm just going to abbreviate. Okay, what about 15? We've already got hypotenuse, so is 15, sorry? Oh, is it opposite or adjacent? it's opposite. 15 is opposite C. Opposite. And how about 8? So that leaves adjacent. So 8 is adjacent. And then we're looking for cosine. So this tool really helps me. So toa. So we're looking for cosine. Cosine is adjacent over hypotenuse. You can also use your notes, so that really helps me. So adjacent over hypotenuse. So the cosine of C would be adjacent side, which is 8, over the hypotenuse, which is 17. And that's all. We cannot simplify this number, so that's all we need. Okay? Questions on that? So we're just following those relationships. Oops. There we go. So that's 4.
So hypotenuse is the one that crosses 90.
Yes, always. Yep. And it's always the longest.
C is longest.
The hypotenuse, always the longest. Yep. Okay. Hi, Sam. All right, these ones are just typing to our calculator, so that's nice. So we just take, those are pretty straightforward. If you need to borrow a calculator, there's some. Yep, all you have to do is type it in. Is that what you're saying? For this part, this second section is really easy. So let's look at 11. So we're looking for the tangent of 97. So we just do tangent, 79, enter. Tangent of 79 would be 5.1. 5.1. It says nearest 10,000, so maybe let's do, that's it. 10,000. We'll just go one decimal. Okay. 5.1. So you just type those in. Those are nice. All right, these ones are a little bit tricky because we have to do some algebra. So look through 13 through 18. Which one should we do together? Sam, we're on the second page. We're working through some together. 17. Okay. 14. You change your mind? Okay. Let's do 17 because there's more space for me to work. All right, so we have this side, and we have this angle. We're looking for this side. We have this angle. So first, let's label our sides. What do we have over here? How is 20 related to the 40-degree angle? Will this be our hypotenuse, our adjacent, or our opposite? So adjacent makes part of the angle. Adjacent is part of the angle. So it's not adjacent. Good, it's opposite. Good, so it's opposite. No, these won't be the same size. So this is opposite. X would be adjacent. So what relationship relates adjacent and opposite? So this helps me again. So toa. So we're looking for one that has opposite and adjacent. So which one is that? So this is opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So tangent is the one that we're going to use. Here's the paper. We're on page 2, or 17. So tangent of our angle, so the tangent always has to go with an angle. So tangent of 40 is opposite, which is 20, opposite over adjacent. The adjacent is x. So this is a good one. This one's harder. So we're looking for x. We're trying to get x by itself. So first we can't work with x in the denominator very well. So we have 20 divided by x. So to get the x out of the denominator, we're going to multiply by x. So that will get x on this side. Now x is in the numerator. X is on the top. And now we're going to divide both sides by tangent of 40. So let's rewrite what we have. We have x times tangent of 40 is 20. So now to get x by itself, I have x times tangent of 40. So the opposite of multiply is divide. So I'm going to divide both sides by tangent of 40. Now I have x is, and I can plug this in my calculator. Scoot that over. There we go. So I have 20 divided by tangent of 40 end parenthesis. And there we go. So that is 23.8. We'll just go to one decimal today. You will have to do the algebra part on paper to make sure that you get the x in the right spot. Yep. Okay. Do you guys see that one? Do you have questions? All right, go ahead and look at the next page. So look at 19 through 24 and decide which one we should do together. 19? Okay. All right. So now, this is where we have to use the inverse. So we have this angle. Let's call it theta. A lot of the time, we're going to call it the angle theta. We could call it whatever variable, but a lot of the time, an angle is theta. And what do we have? What sides do we have? What side would this be called? Is it going to be the hypotenuse? Is it opposite? Is it adjacent? Good. This one is opposite. Perfect. How about this one? 44. It is adjacent, but it's also the hypotenuse. So we're going to call it the hypotenuse because it's across from the 90. So this one is hypotenuse. This one would be adjacent, but we just don't have the number there. Okay, so SOHCAHTOA, we need a relationship that relates the hypotenuse and the opposite side. So which function should we choose? Opposite and hypotenuse. So this one, sine. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we have these two. We have opposite over hypotenuse. So sine of theta, sine of this angle, is opposite over hypotenuse. So sine of theta is the opposite side, 39 over the hypotenuse, which is 44. And then we have to do the inverse sine. So that's where we do sine inverse on this side to get rid of that sine. And we're going to do sine inverse of this function on the other side. So if we do the sine inverse on one side, we have to do the sine inverse on the other side. So the sine inverses cancel. We have theta on this side. And then we're just going to type in sine inverse of the number on the other side. So sine, so second sine, that gives us the inverse. And then we do 39 divided by 44. And our theta is 62.4 degrees. And that's what we need to find. Okay. Questions on that? So first label your sides, figure out what function you need to use, and then just do the inverse function on the sides. Okay, last kind down here. This is also inverse sine. So if we have sine of this equals this number, all we have to do is do the sine inverse to cancel out sine and find x. So x is sine inverse of 0.7547. So this one you just have to plug in your calculator. So we just do second sine inverse of 0.7547 and parenthesis enter. So x is 48.999. So let's round up. Let's do 49.0. Okay. So these ones are pretty easy. All you have to do is the inverse function. All right, questions before I let you try them by yourselves? Okay, so we'll just have work time. If you guys finish, feel free to work on other work. So there's just 30. These shouldn't take you too long, so if you're getting stuck, let me know and we can work through some, okay? If you need to borrow a calculator, there's some calculators in the bin.